In 1990, a missile entered service with the Royal Air Force, and it was ultimately retired in 2013. The missile, not the RAF. This fact in and of itself is very dull, but whilst researching this topic, I started to find this sort of thing as common as popping exhausts that frighten my dogs and make me tut loudly. This is the story of the British Aerospace Alarm Missile. The Ministry of Defence in the 1970s, like most Western militaries of the time, was full of contradiction. They loved innovation and lateral thinking as long as you did it in a known and tried and tested way. Then, having observed the threat of the new Soviet surface-to-air missile systems and the effectiveness of American anti-radiation missiles like the Shrike and later the AGM-88 high-speed anti-radiation missile, the Hasam? Harm? What do you mean harm? It's high speed. Okay, all right. The MOD wanted to update its SAM suppression capabilities. Hello world, I'm Scratcher, and this is my video. It took me ages, partly because I have no opposable thumbs. Uh, I'm a small woodland creature about to talk about military hardware, so as you can probably tell, I don't have much charisma, so let's just crack on, shall we? Before going into any details about my favourite missile, yes, you heard me, my favourite, the Hellfire can suck it, I want to mention some examples of products that defence engineering can create, and the popular public perception might not quite be deserved for some of these products. In 1946, the MOD issued Operational Requirement 230, which defined the next generation of nuclear-capable heavy bomber. Designs were received from the British aeronautical giants, and let's face it, the UK around about that time was in of itself an aeronautical giant. Companies like Armstrong Whitworth, English Electric, Handley Page, Avro, Shorts Brothers, Vickers Armstrong, and more, most of which don't exist today. Hang on, wait a minute, it says 3 of the designs were accepted. What? Hang on a second. Yeah, so 3 of the designs were accepted because the MOD were hedging their bets. Like any decisive organisation, they were, however, only able to accept 3 designs so long as they scaled back the orders for the English Electric Canberra, which was also quite capable and popular at the time. This trio became known as the V-Force. One of its products is the now legendary Vulcan. It saw service from 1956 until 1984, having had an illustrious career as a nuclear deterrent, a conventional bomber, maritime reconnaissance, and briefly as an air-to-air refueler. And then it did something truly amazing. It came back from the dead for a few years. The Vulcan is loved and admired and had a 28-year military career. That's quite a machine. The Victor flew for the RAF from 1957 for a whopping 36 years, with its last 18 or so as a very successful air-to-air refueling platform. The Victor was also lucky enough to mark its place in history by being arguably the star of the Black Buck missions of the Falkland conflicts. That's probably about as controversial as I get in this video here. Yeah, you heard me. The Vulcan wouldn't have got as far if it wasn't for the Victor. Anyway, the Victor ended its career supporting Allied aircraft during the Gulf War. And that's also quite a machine. Then we have the Valiant, the lesser remembered and often overlooked member of the V-Force, operational from 1955, before the other 2 aircraft. It had state-of-the-art navigation and bombing system. It could hit a target from 45,000 foot to within a few meters, practically a sniper in its day. The Valiant, rumbling for a fight, saw combat in 1956 during the Suez Crisis in the conventional bombing role, and that was only 1 year after it entered service. It had no operational losses. Tanker conversions were operational from 1958. It was also fitted out for electronic warfare, but forget about all that because it will only be remembered for one thing. The increased threat of Soviet air defense systems meant that high altitude is out. People want a little more low level these days. Bear in mind, scudding through the valleys was not part of the design criteria. In the late 50s, flight trials out of Boscombe Down began, and to the shock of the engineers, wing spar cracks were found in the prototype Valiant that was used. But because the production final design had reinforced spars, the leadership decided to potentially let the operational crews enjoy this shock to some years down the road. In 1964, these wing spar cracks started to appear in the production fleet, and that sealed the fate of the Valiant. Luckily, they lost no aircraft to it. The Valiant is often overlooked and seen as the weakest Avenger. And because the MOD were able to secure a budget that could finance 3 airframe designs, they were able to retire the Valiant early with minimal impact to the overall strategic fleet. The Valiant gave the required operational capability before the others even flew. It had some of the most sophisticated tech of the day. Sadly, though, it's always going to be remembered for its failure. The Valiant became the V-Force fall guy. Next up, we have the torpedo ram. So, circa 1880, this design of battleship came shortly after the introduction of the torpedo itself. The purpose of the ship was to attack stationary ships because that's not a terrible idea. Using torpedoes that were either below the waterline, which meant the attacker had to be practically stopped, especially if using side firing tubes, or at very least at a reduced speed if using forward-facing tubes. Otherwise, the ram could collide with the torpedo that it had just launched. Or using torpedoes launched from above the waterline, which were prone to exploding, especially in combat conditions, especially if the armor was thin. Jesus. The ship would run with its deck almost awash, providing a very low profile, and as its name suggests, would be capable of ramming its target once it had depleted its torpedoes. Did anyone actually volunteer for this? Because after 10 years, the class being in active service, not one recorded hit, let alone kill. The class was all but abandoned by the turn of the 20th century, but it does live in infamy as being the only weapon that could take down an alien invader from Jeff Wayne's War of the Worlds. Other honourable mentions include the anti-tank Vesper. This had a 3-year production run and were loved by the bean counters because of the cost to potential kill ratio. Its mobility suited hit-and-run tactics against light vehicles and fixed emplacements, although pretty much useless against any tanks. Despite being a bit rubbish, it was employed with some success. Also, the Hafner rotor buggy, which was basically a Willis Jeep paired with a rotor kite. Not an autogyro. Okay, they're different things. This design was abandoned when it was discovered that you could make gliders big enough to carry Jeeps, and that it was a crazy idea, but it was worth a try, I guess. Imagine that, the D-Day landing supported by towed rotor flying Jeeps. Thank goodness that never came to be, eh? Right, with that out of the way, 1983. The year of Flashdance was also the year the alarm was selected over the harm because of the requirements set out in ASR 1228. This is the document that really got things rolling for the alarm missile. The UK wanted to retire the Martel AS-37 anti-radiation missile. It was slow, it was heavy, it was slow, its sensors could only be tuned on the ground, it was slow. The weapon was very successful at the time, but as the Soviet SAM tech increased, it meant that anti-radiation missiles could be shot down, which is no good for a slow missile. Did I say this missile was slow? It's a bit slow. ASR 1228 is a public document written initially in 1978. Currently, it's held by the MOD, but I'm yet to see it. It took the MOD's Freedom of Information team over 10 weeks to locate and vet the document, which tells me two things. The department is seriously under-resourced, so shout out to the Foy boys. And when you see any references online about ASR 1228, the odds are the author of the article hasn't actually seen the document, and this is perhaps the first time it's been released into public, maybe. The document that was sent to me consisted of two PDF files totaling 34 megabytes of data covering over 340 pages and includes lots of political context, like concerns how adopting the UK system would affect future purchases from the US. This choice even informed how we went about developing the Sea Eagle over the Harpoon, Automat, or Exocet anti-surface missiles. I've left a link to it below. It's fascinating to read the opinions of the time, but it is quite long and dry and a little bit repetitive. I'm a slow reader, so this is also why it's taken me a while. However, I will cover some of the technical requirements finalised in 1983, since I've gone to this effort. The missile is made specifically for the GR1 Tornado, to be compatible with the standard loadouts of fuel tanks, countermeasure pods, 540-pound and 1,000-pound bombs, the BL-755 cluster units, the JP-233 runway denial weapon, paved way, and the WE-177 nuclear bomb. That's cheery, isn't it? It was to enter service by 1986 and capable of detecting and destroying Warsaw Pact radars used for the SA-345, the SA-6, SA-8, SA-10, SA-11, and ZSU-23 systems, just for starters, and defining destroy as to make inoperable for 24 hours. It's important to make that distinction, I suppose. These requirements also stated that the preferred loadout would be the JP-233 runway denial kit. It would be capable of being programmed on the ground and in the air by crews, whilst under the wing, and audibly inform the crew of any detected emissions. It should have a minimum range of 30 kilometres. It's to be launched nominally from 200 foot above ground level, possibly down to 100 foot whilst flying over high terrain, and also to be launched at high subsonic speeds. This requirement matched the favoured interdiction technique of the time, and it was also the flight profile used by the Tornado. The requirements were given to two parties, Texas Instruments, who had already produced the successful AGM-88 HARM, and British Aerospace Dynamics, who have produced nothing up to this point. Now, this is the sort of decision that British politicians have had to face dozens of times. Do we choose the pre-built and so far tried and tested and therefore cheaper and easier to implement solution that just about meets some of the requirements, like some short-sighted cheapskate, or do we build it locally, which brings jobs and export opportunities at the great cost of money and increased development time, not to mention putting the whole project at risk if this requirement falls out of favour, especially if a new government is to be elected? All of this has happened before with the TSR-2, and to be honest, as much as the TSR-2 promised the world, and God, I love that aircraft. Whenever I've been to Duxford or the Imperial War Museum, I've spent half my time swooning over this flipping thing. It's probably a good thing that it never actually had a chance to fail operationally. Let me explain. In the early 1960s, we wanted a supersonic low-level bomber to deliver nuclear-capable long-range cruise missiles. That would become the Blue Steel. No? Yes, okay, that one. Thank you. TSR-2 promised terrain-following radar coupled with the autopilot, sideways-looking synthetic aperture radar, whatever that means. It sounds clever, doesn't it? The small wings gave quite a high wing loading, which reduced buffeting at low altitudes and high speeds. The blown flaps reduced takeoff and landing speeds, which helped it with short runway operations. It was a thing of beauty, but it was being distorted during its development by increasing costs and the American F-111, which was also being developed at the time. The TSR-2 became a political bargaining chip. So when Labour got into power, they canned it in preference of the F-111. But I never knew the F-111 was ever in service with the RAF, you might say, and you'd be right. Again, cost overruns also plagued the F-111. The RAF went without a nuclear deterrent capability until the Tornado came in, nearly 20 years later. Nice one. Okay, so back to our story. Michael Heseltine, who was the defence minister, whilst not trying to link CND, the Labour Party, and the Soviets together, he selected the alarm based on it exceeding the requirements set out in ASR 1228, and also this supported British industry. So there was, however, huge concern over how this news would be met by the Americans, so tact and careful discussion was planned because the Conservatives are really good at that sort of thing. Anyway, there was an option to co-produce a harm variant that could better meet these requirements, but there was concern over being tied into a project where the UK would still hold some financial risk and there was no guarantee of what additional industrial man hours would come to the UK. So the decision to produce 750 alarm missiles for £388 million, which is £150 million more than the equivalent harm deal, was made. The development of the alarm was mostly uneventful, barring some concerns over one of the rocket motors because of the required loiter mode. Yes, so this is where we start to see why this is my favourite missile. This isn't just your daddy's Shrike. So problems with the Royal Ordnance rocket motor nuthatch, nuthatch. This led to some delays, renegotiating with Bayern Chemie, who would deliver the replacement motors. All this happened around about the same time British Aerospace acquired Royal Ordnance, so make of that what you will. Lucas Aerospace were also hoping to benefit from the harm deal. Lucas and Texas Instruments both lobbied the UK government to favour their offering, which, in all fairness, was also preferred by the RAF, as it was tried and tested and ready to roll. The UK military don't like change, as we've discussed earlier. However, even if they went with the harm, there was a good chance that the UK would insist on developing their own Seekerhead, likely manufactured by Lucas Aerospace, and then they'd try to install it on the US weapon. The alarm became a political hot potato for a while. Decisions and press releases were withheld until after the 1983 general election. And there were concerns that if we didn't go ahead with the US harm deal, that would affect other transatlantic projects. The Harrier for the US Marines, for example, and the Hawk trainer were both recorded as at risk from this. The Defense Secretary, who was fully aware of the power that US Congress had, but ultimately he went against the RAF, the US, and the Treasury, and opted to generate skills and jobs for the UK for what was deemed to be the better weapon. Not to mention that British Aerospace had already begun work beyond the concept stage at their own cost. I can only speculate as to why this is. It all seems a little bit sus, doesn't it? Right, okay, so with the political background out of the way, some technical things now. So, what anti-radiation missile doing? Well, let's have a quick look. Its Seekerhead is fully autonomous and able to differentiate between different emission sources. There's still very little information released about how it works, but it is the size of the Shrike Seekerhead with similar capabilities of the Harm. It has electronic there's only two counters there, countermeasures, and it's able to prioritize and reprioritize targets mid-flight. Pretty smart piece of kit there. The brain is the Missile Control Unit, the MCU. This houses the governing software. It also provides the interface to the launch platforms, the Tornado, and also has the inertial reference system built in. This is quite a feat because it is a small weapon. The practical upshot of using an inertial reference system is that when a target emitter is identified, the missile will map the target's location and it can remember it accurately, even if the targeted broadcasting station switches off. For 1980s tech, this is amazing. The harm didn't get anything like this until after 2000 with the AGM-88D for Delta. The fuse is a laser rangefinder because the terminal phase is a vertical drop onto the target. When the seeker identifies an emitter, it looks up the frequency in a cross-reference table against known antenna heights. Nerds! The warhead is an armor-piercing fragmentation type. Again, the warhead is also smaller than other missiles as it drops straight down on the target, meaning it can home in on the vertical side lobes rather than the more conventional method of using horizontal side lobes. This is pretty clever stuff. I only understand 1/3 of what I'm saying. The alarm has a few different modes of operation, but can be simplified as direct and indirect. Direct is a conventional method where the weapon is fired at an identified threat. If the emitter switches off, then the next best target is selected by the seeker and the MCU. The first indirect mode is also known as loiter mode. The missile is fired in a direction of a known threat that is currently not emitting. This is my favourite mode of the missile. And here's why. When the alarm is fired, it climbs to about 40 to 45,000 feet. It deploys a parachute and slowly descends while scanning for emitters. When one lights up, Big Brother here jettisons its chute, fires up the second rocket motor, and merrily drops onto the target, removing the burden of life from the surface-to-air missile site's to-do list. Mode 3 is basically a version of the direct mode, but if the target site is lost, then the alarm switches to loiter mode. Then it soon climbs to high altitude and waits for the site to come back online, and then after a small explosion, offline. The last two modes, the missile zoom climbs up and descends in a slight dive under its own inertia, scanning for targets. One mode for low altitude launch and one for medium or high altitude launch, basically creating a suppression corridor. The high altitude mode can give the missile a 50 nautical mile range, which can increase if you are launching it in a 4G climb. The alarm eventually saw action in both Gulf Wars and in Yugoslavia in 1999, and it was very good at its job. There are reports that when employed alongside the American AGM-88 HARM, the HARM missile would suppress air defences suitably during an airstrike. But once the SAMs have sat through all the explosions and everything was over, to confirm that the coalition aircraft were gone, they would light their radars back up to check that the coast was clear, only to have our parachute boy here drop on them from a great height. So there we go. 2013 rolled up and the alarm was retired from service with the UK. It was only exported to Saudi Arabia, where it's currently still in service as of 2023. Apart from that, exports never happened, possibly because of the unit cost. Despite exceeding our requirements, government treasuries don't usually want to pay over the odds for things they don't have to. The AGM-88 is still around, dominating the market up to the G model, with the AARGM-ER, AARGMER, yeah, AARGM, there we go. And that's expected to be used with the F-35 and Eurofighter Typhoon. The alarm did gain a little bit of notoriety in only a few places. It featured in the 1993 game Tornado by Digital Integration, and again in Digital Image Design's EF2000, both great flight sims of the time. I spent stupid amount of time playing those. And very briefly, it appeared on Sky News during the Second Gulf War. I remember watching this report. The cruciform parachute was spotted falling into the reeds in a local river by Iraqi soldiers who promptly war crimed their way into history by shooting at what they thought was an ejected pilot live on international news. So I'm still trying to find that footage now. The alarm was truly a result of British engineering in that it innovated. It got the job done discreetly and efficiently, and it surpassed its competition in quality and effectiveness. It then retired quietly after a distinguished career. Unlike the Vulcan that is fondly remembered by many, the alarm will only be remembered by a few professionals and dorks like me. Uh, and that's my favourite missile. Suck it, Hellfire. And just finally, a quick note. Thank you to my 85 subscribers for subscribing, and anyone who's sat through me rambling on for the best part of half an hour. I do just want to say thank you to Lord HardThrasher for giving me a little bit of guidance in creating this video. If you haven't subscribed to him, please do. His stuff is really entertaining and informative. It's great, so long as Jenkins isn't cocking things up for him. His videos go great. And to be fair, I was only sort of directed towards him because of LazerPig. So please also uh, subscribe to him too. Right, thank you, and good night.